Hello everyone, good morning. In today's session, we are going to talk about what is SQL, okay, and what is database versus data warehouse, and we are going to see few of the DDL operations, okay, what is DDL and how to create a table, okay, how to insert the data and how to do bulk insert, okay, and we are going to see, okay, create, insert, delete and drop. Okay, these are the major concepts which we are going to discuss today. And in order to practice, okay, so we need to have a account, okay, you need to have an account. So how to create an account? So you need to go to any browser, just give app.snowflake.com. Here you need to create. It's like you need to click on sign up. You need to provide your first name and last name and your email ID and why you are going to sign up. Then if you give continue, you can see what kind of edition we need to select and what kind of cloud you are going to select. As soon as if you submit the form, so what will happen? You are going to get this kind of link, okay? So here you can see click to activate. Click to activate. So here you can provide your username. So we take Batch-12. I'll keep it like this. Then you can set your password, one password. And click on get started. So here you can see there are 400 credits and the trial ends in 118 days. Okay, so we have created an account for 120 days account, right? Suppose if you want to sign out, yes, you can sign out here. You can sign out here. So this is how we can create the account. So you need to remember your username and dedicated login URL. So this is very important. Okay, this is very important. So in order to log in into your Snowflake, then you need to provide your username. Then what is Snowflake? Anyone? Can someone please tell me? So what is Snowflake?
Yeah.
What is Snowflake? Anyone?
Snowflake is an cloud-based data warehouse platform, sir.
Yes, very good. So Snowflake is a cloud-based data warehouse platform. Next point.
Sir,
So
it offers
yes.
Sir, it offers data storage, data processing, and analytical services.
Data storage, data processing, and analytical solutions. Yes. So you can store the data for processing. We can use for analytical solutions also. You can use this. Next one. It is built on top of
AWS and Microsoft Azure and Google
GCP.
Cloud Platform.
yes, correct. Azure and GCP. Next.
We can store structured, semi-structured, and unstructured.
Yes, correct. We can store structured, semi-structured, and unstructured data. Next one.
It is available as
available
SaaS
as
model, sir.
SaaS model.
Yes. So that means you no need to install any softwares.
Software.
So it's available as a, so it's very, very important, guys. Okay. It is available as a SaaS model. Software as a service. Okay, it's very important. See, Snowflake is a cloud-based data warehouse platform. Mainly, we are going to use it for, or it offers data storage, data processing, and analytical solutions. It built on top of AWS or Azure or GCP. We can store structured data and semi-structured data and unstructured data. And it is available as a software as a service model. Correct. And as we discussed yesterday, in today, okay, the first 5 sessions, okay, first 5 sessions, we are going to talk about SQL. Okay. So how many of you know about SQL? I mean, basic idea.
It is a structured query language.
Yeah, a structured query language. But have you worked on SQL earlier?
No, sir.
Maybe in your college days you have worked on how to create table and how to create database, what is schema and everything. Okay. And a few of the students may know or may not know. So that is the reason. First 5 classes, okay, we'll talk about SQL. Then we'll jump into Snowflake. Okay. So this is the prerequisite. So you need to have a knowledge on SQL. Okay. So here, what is SQL? Correct. SQL is a structured query language. So before going to talk about SQL, yes, before going to talk about SQL, you need to know what is database. Okay, first of all, what is database? So database is nothing but collection of data. So what kind of data? It can be structured or semi-structured or unstructured data. Okay, if you take any example for bank, you can consider bank is a database. Bank is a database. So inside, so we have a table. So employee table. So this kind of data, we are going to store it in a tabular format. What is table again? Table, it consists of rows and columns. Rows and columns is nothing but a table. So this kind of data where we are storing. So we are going to store it in a databases. Okay, we are going to store it in database. So that is the reason. So database is nothing but collection of data. Any kind of data, you can store it in your database. Okay. Then how to store this? How to store this? Okay. How to store it in a database? It's very important. So by using SQL, we are going to store the data. So then what is SQL here? Structured query language. It's a definition. Yes. Structured query language. So it's like a basic English language. Okay. Before this, okay, it's like basic English language. So if you know how to speak basic English, then definitely 100% or 200% you can able to manage SQL. Okay. The main definition of SQL is not abbreviation. Okay. So it's like observation, like structured query language. So it's like a basic English language. correct, but the formal definition is in order to communicate with any database, we are going to use SQL. See, SQL is different and database is different. See, most of the students who are failing in interviews, they are saying like, okay, SQL is a database. So that is wrong. SQL is not a database. SQL is not a database. See how we are interacting by using teams, right? The same way, in order to interact with any databases, we are going to use SQL. Then what kind of databases we have? Database examples. Okay, database examples. So we have MySQL, Oracle, Sybase, MSsql. So we do have a lot of, okay. We do have postgrage. Okay. So these are the databases we have. See, Snowflake also we can use it for data storage and data processing and analytical solution. It's also kind of database, but more than a database. Okay, Snowflake, redshift. Okay, so we do have many in the market. In order to interact with these databases, okay, in order to interact with these databases, we need an SQL. We need SQL. Without SQL, we are unable to interact with your databases. So that is the reason SQL is a structured query language. It's like a basic English language. In order to communicate with any database, we are going to use SQL. If someone is going to ask, okay, where we are going to store the data, you have to answer like we are going to store the data in Snowflake or MySQL or Oracle or somewhere by using SQL. You should not say like, okay, SQL is a database. That is very important. Okay. SQL is a database. Yes or no? No. But this statement is correct. SQL is not a database. SQL is a database. Someone is going to confuse you. SQL is database. Okay. Now let's create one database here. Okay. Let's create one database. Then before going to create, what is database and what is the major difference between data warehouse? We will see this. So database we have already discussed. Okay. Database is nothing but a collection of data. So here in the database, we are storing the real-time data. We are storing the real-time data. For example, you can consider as the bank. You are going to deposit 5,000 into your account. So it's like a immediate actions. It's like immediate actions. So because here we are storing the real-time data. Then, so if you deposit something, so within 5 minutes or within 2 minutes itself, okay, within 2 minutes, you will get a message, correct? Within 2 minutes, you will get a SMS. So because it is real time, okay? Then what is the data warehouse? So what is the use of? So normally we do have warehouses. It's like normal warehouses, what we are storing, we are going to store the logistics and so bulk data. Okay, so here mainly we are going to store historical data. So what is historical data? I'll tell you. Okay, we are storing the historical data. We are storing the historical data. So even in the same example, it's like a bank. So you are going to perform some transactions 1 to 7 months or 1 to 12 months. So we have done some transactions. So there are 200 rows we have inserted into your database. After 12 months, we are moving the data into your warehouses. It's like that is the historical data. So we don't want to keep entire data into your databases. We are going to store the historical data into your data warehouses. So that is the thing which we are doing. The best example here, if you take any mini statement, okay, mini statement, if you want a mini statement for before 5 years. So you want to see all this 5 years data. So what you have done, then it may take some time. It may take, it's not immediate. It will take 5 minutes or 10 minutes to download. Okay. So because we do have lot of transactions, out of that lot of transactions, okay, it will take some time to fetch these details. But if we have less records, it is taking less time, and also we are storing the real-time data in the databases. And data warehouses, mainly we are storing the historical data and large volume of data, large volumes of data. Okay, this is about theory. Let's jump into the practical now. Now let's create one database. Click on plus button here, click on SQL worksheet. So SQL is not a case sensitive, okay, but data, it is a case sensitive. Either you can create it in small letters or capital letters, it is going to work. Okay, create database. So my database name is bank. Okay, just try to select this one and click on run button. See how simple it is. You have created one database. So what is inside this? So these are the schemas. What is schema? Okay, what is schema? First I'll tell you how to, I'll create one test table here. Okay, I want to create a table. Create table. My table name is EMP. The table name. See, create table, table name. Then you need to provide the columns. Okay, I want to provide the column as ID. Just name, that's it. Okay, these are the two parameters. Just I want to create a table. So here, if you observe, we need to provide the data type here. ID is the column. After this, you need to provide the data type. Either it is integer or number or float. So what is name? Name, it is a string. Either you can use string or varchar. Okay, we will talk about the data types too. Just create one table. So this is my table. See, now table is created. Okay, now table is created. So you can consider this is for HDFC Bank, which we have created the table. So how to comment? Okay, comment lines are like two hyphens. So this is like we can comment the SQL statements. So, okay, I want to comment this. Yes, you can comment it. Okay, create table, employee EMP. Okay, integer, it's a string. Okay, fine. Now I want to create the same table for ICICI Bank. Suppose if you try to execute this statement, so here you are going to store the HDFC data. So here you need to store the ICICI. I don't want to complicate. It's like I don't want to insert all the data into single table. See here what it is showing. Object EMP, it's already exists. So within one database, we are unable to create, okay, within one database, we are unable to create the duplicate table names. But how to achieve this? How to create for each bank as a different table names. Okay, that you can do EMP1 or EMP HDFC something, but I want to create a same table name. So here only the schema came into the picture. I'll show you diagrammatically. Okay, MS Paint, let me take. So this is my database. So you cannot create the separate tables. Yeah, you can create the separate tables, but the same table we are unable to create. So that is the reason what you can do, you can create schemas. So inside the schemas, you can create again the tables. Okay. So first one, what is this? This is database. So this is database. This is like schema. So one for HDFC and another one for ICICI. Next one is for Axis. Next, inside this, I'm going to create a table name called EMP. So here also EMP. So here also EMP. See the same name which I have designed. Okay. So inside this table consists of rows and columns. The same thing we are going to replicate into our Snowflake account. Okay. See here. So first one, it's a database. So it's a number one. On inside the database, what we have, we need to have a schemas. Then inside the schemas, what we are having, we have a tables. Then what is schema here? So what is the use of schema? See, without creating the schema, so you cannot create the duplicate objects or duplicate tables. Okay. And also the main definition of schema is it's like a logical representation of the database. So schema is nothing but it's a logical representation. See, logically we are logical representation of database. Okay. So we are logically segregating the things here. Okay. Now we'll go to database. So what is our database? Bank is our database. So inside the bank we have created EMP, but I'm trying to create one more table for ICICI. It is not possible. So that is the reason we came up with an idea like schemas. Okay. We need to create a schemas, separate schemas, HDFC, ICICI or Axis. Okay. How to create schema? It's very simple. See the same thing. Create schema and schema name. What is the schema name? HDFC. Okay. Then create one more schema. IC. Yes. Then create how many you want, you can create it. Okay. Access. Now I want to execute all three at the same time. Yes, we can do. Select all and click on this. Now I'll just do refresh here. See here, Axis, we have empty, HDFC is there, ICICI is there. Now I want to create this table inside the HDFC. there are two ways. Either you can select this option, bank. So here, okay, it is showing only public. Later you can search HDFC, it will also come. Okay, if you do refresh, it will come. Or else what you can do, while creation of the table itself, database name. So bank is the database, bank dot HDFC dot EMP. So this means first one is denotes to bank as the database, schema and table name. So this is very important. Okay, like this you can create it. Now just to refresh, see HDFC inside EMP we have created within one database. Now for IC, you have created one schema, then you can do this. See here, earlier within one database we are unable to create with the same name. So now it is very easy by using the schemas. Okay, so first you create the database, then create the schemas. Inside the schemas you can create the tables. Okay, you can create the tables. And I forget to tell one point. Okay, see SQL. What is SQL? In order to communicate with any database, we are going to use SQL. What kind of communication we are doing? So it's like we are going to perform CRUD operations. What is CRUD? C means create, R means read, U means update, D means delete. So these are the actions only we are going to perform by using SQL. Either you are going to create, either you are going to read the data, or you are going to update the data, or you are going to delete the data. So these are the actions we are going to perform. Now we have created the table, correct? So this is how you can create the tables, and you can segregate the schemas also within one database. This is up to you, either you want to create the separate schemas or not, but the industry standards, we need to create separate schemas. Inside the schemas you can create the tables or views or something. Okay, just fine. I'll show you one more picture here. SQL Snowdocs. So what are the sub languages of SQL? So this is also one of the important interview question. Okay, sometimes the interviewer is going to ask, okay, what are the sub languages of SQL? DDL, data definition language. DML, data manipulation language. TCL, transaction control language. DQL, data query language. DCL, data control language. Okay, inside DDLs, see DDLs in the sense it's like mostly you will get create, drop, alter and truncate. Again DML, you have like, okay, insert, update, delete and merge also we have. Okay, fine. Then TCL means commit, save point, rollback. So just you need to remember, okay, so there are 5 sub languages: DDL, DML, TCL and DQL, DCL. Just to prepare a notes for this also. So this is very important. Okay, under DDL we have create, drop, alter and truncate, insert, update and delete, commit, save point and rollback, select and grant and revoke. Okay, so in detail we'll talk about later in this diagram. Okay, just remember these points. See everything, see it's a all these sessions it will be like a technical mode only. So what are the things we are going to do it in real time? So those things only I'm going to showcase here. Okay, I'm going to showcase here. Now try to see my requirement. Okay, now we have an idea what is database and what is schema and what is table, how to create the tables within the same database, how we can create the same table name by using schemas. Okay, Now there is a requirement. So this is my requirement. So we do have one spreadsheet or Excel sheet. Okay. I want to create this kind of table and I want to insert this data. So what is your approach? Okay, so first I'll take you from 0 level, like, okay, let's see. So let's copy these columns. Okay, just copy these columns. So later we will use AI and all. Okay, as of now, don't use AI. It's like initial stage, right? Now I want to create a table. Yes, want to create a table. Create table. Table name. I am going to keep it as employee. Employee is my table. Now just open the braces. Okay, just open the braces and close the braces inside this. Just copy paste all the columns, whatever you want. Okay, just like this. See, this is for which you are having. I mean, how many columns are there? 1, 3, 6. Okay, 10 columns it is there. Suppose if it is 100 columns also, same procedure only. You no need to worry about this. You no need to worry about. Okay, create table, table name, the column names you have given here. Next, by seeing this, you can tell me. So what is this 100? Either it is a numeric or string value. It's a numeric value. So what we can do? So if it is numeric, either you can use number. So how many numbers you want to store? Either 3 or 5 or whatever it is. Or else what you can do by default integer. Okay. Then first name. So here it contains the characters. Then you can use char, or either you can use char or varchar or string. Okay, Snowflake is going to support. Okay, now in real time, okay, you don't know what to use and where I need to refer these columns and what are the data types. So Snowflake has provided, okay, the very good documentation. Okay, Snowflake data types documentation. Okay, so it's like this is the Snowflake documentation. So whenever you want to refer, yes, you can refer this. Okay, I'll give you this link also. So entire class notes, it will be available in the video description as of now. And after completion of the demo sessions, I'm going to create the classroom notes so that you can able to access directly. See here, see numerical types. Either you can use number, decimals, integers, small int. Okay, if it is a character, okay, if it is a char, either you can use char, varchar or string. Okay, if it is a date format, I can use date and time. So these are the data types. So by seeing the data, you have to decide what kind of data type it is. Okay, so mainly we are going to work with numbers, strings. Okay, numbers or strings or date and time or decimals. Okay, that's it mostly. Then just you can write here, simply I'll keep it as string. Okay, last name also string, email also string, the phone number. So see here, numbers as well as some dots will be there. Then you can use the string only. If you are having only numbers, then you can use integer. Then higher date. So date will be in a date format. Job ID, integer, integer, integer. Okay, everything it is integer. Okay. So here it will be salary will be decimal. Okay. So decimal, how many bytes you need to store? Okay. So that you need to mention here, or else you can give the float also. Okay, that's fine. Manager ID integer. So department ID integer. See, that's simple it is. Okay, that's simple it is. So this is how you can create the table. This is how you can create the table. So let's create it. See, table is created. Where it is created? See, bank dot public it is created because you didn't mention the proper schema name, or else you need to select the schema name here. Okay, I want to create this table in a axis. Okay, let's see. Okay, it is created. Now either it is created or not. Okay, how you will see? You can go to particular schema. So here you can see the definition also. See, this is the table definition which you have created. So this means DDL. Yes. Now I want to insert some data for testing purpose. Okay, I want to insert some data for testing purpose. So normally what we will do, you need to write a insert query. You can consider. So there are 40 rows. Now I want to insert this data. You need to write a insert queries. So how many insert queries you need to write? You need to write 40 insert queries. It will take, see, one query, how much time it will take? Let's see now. So insert into table name, employee, then column names, all the column names you need to mention here. Okay, so what are the columns we have? Just mention here. Okay, employee ID, comma, first name, comma, last name, comma, email, phone number, hire date, job ID, salary, manager ID, department ID. Yes. Then you need to provide the values. Again, open braces and close braces. Copy this data. Just copy this. So if it is integer, not required. Apart from integer, if it is a string, what you need to do is you need to keep everything, it is in a single quotes. First name, comma, last name, so this is your email. Yes, comma. Yes, this is also one of the string, single quotes, comma. So date, and keep it in a single quotes. Then all are integers. Then keep it as okay. Then close it. See, this is how you need to write manually for all the rows. Okay, unexpected. Unexpected 4 here. Okay, let's see what is this. Okay, there is a comma, it is missing. So date is not recognized. Okay, same data only we have taken. Okay, so now so the format issue. Okay, got it. So the year you need to provide, then 07 or 08. Okay, whatever it is. Let's try to insert. So employee ID, first name, last name, email, phone number, hire date, okay, job ID, salary, okay, manager ID and department ID. I fixed SB4, number out of representable range. Okay. So let me reduce. See this kind of issues. Okay, let's see. So getting the errors. So that is fine. So by seeing the errors only, you will be able to learn the things. Okay, Snowflake number out of range. Yes, correct. You have given number 10 out of 6. Okay, that's fine. Okay. In this case, what I will do, so as of now, okay, I'll keep it as okay, create or replace table employee. Okay, I don't want to store in a decimal format, just like an integer. Okay, I'll store it. See, one row it is inserted. Now, see how much time it took, almost 2 to 3 minutes to prepare this query. It is taking. Okay. Now, if you want to insert one more row, what you need to do? Again, you need to copy paste the same query and you have to modify this data 102. Okay. So something like this. So you have to write. But instead of doing this, so there is a way, I'll tell you. See, you have to write every time this kind of script and you have to run this. Now let's see how many values are there. In order to retrieve the values, select star from employee. Okay, select star from employee, you can provide. See, there are 2 values. Now, instead of doing this, what you can do, instead of preparing this query and everything, okay, you can go to corresponding table here. Okay, corresponding table. So here you can see load data. Okay, load data. Click on this browse option. So where is your file located? So my file is located in D drive, files, okay, employees.csv. Okay, so this is my file. So where you want to insert, okay, bank.access, then employee is the table name. Click on next. So here, if you see here, view options. So what is there in first line? First line, it is header. Okay, not required to insert this. Then header, first line contains the header, field delimiter, skip first line. Okay, skip first line, then click on this load. So error on line 2, characters 58, column 6. Okay, let it be. It's not recognized. Create or replace table. Okay, see the data which it is not in a correct format. So what I will do, I'll consider as this one also string, or else you need to modify the data, and you need to insert. So what I will do, this one also just I'll create it as a string. Okay, now simply we have created one table. So after creation of the table, just I want to load the data without writing any queries. See, I don't want to write this. So this kind of options we have in a Snowflake. So it's like a time saving. See, no need to write any scripts. So click on this file, click on the database, go to view options, skip first line, load data. See how many rows? 40 rows inserted successfully. Now click on done. Now, in order to retrieve the data, we need to use select star from employee. Okay, select star from employee. See how beauty it is. We are not writing even single SQL query, just we have a data. So we have loaded this data into Snowflake within 1 minute itself. So here you can see. So we do have a chart option also. See, this is called for analyticals. Okay, so I want to see, so which person is having the highest salary. Okay, so like this, you can add the columns here. So based on the salary, okay, see the person who is having, okay, what is the maximum salary here? See, 24,000 is the maximum value. Then 17,000. See here. So it's like a graphical way also it is going to display. So this kind of feature also it is available in Snowflake. So there is a chart option. So x-axis and y-axis, you need to select, okay, I want to see the name. Okay, I don't want employee ID. So who is having the highest salary? See here, the Steven. I'll show you in a query also. See here, Steven, it is having the 24,000, next 22,000, 17,000, something like this. So this way, instead of writing the SQL also, we can easily identify who is having the maximum salary. Here, see, I'll write a query here. Select star from employees. Order by salary, descending order, so that you will get to know. Okay, what is order by, what is descending, everything we are going to discuss, but just try to see here. See, the person who is having the highest salary is 24,000 here. So earlier also we have seen the same thing in a graph. Okay, so this is what, so that is the beauty of Snowflake. You don't need to write custom queries here. Just directly you can load the data and you can visualize the data. Okay, we can visualize the data here. Now by default, suppose, so what I have done is, okay, so we have a, this is very important, drop. Okay, let me write here. So what we have seen so far, create, okay, how to create a table and how to create a schema. Now let's see, delete, drop, truncate. So what is delete? So delete is the command. If you want to delete the rows from a table, we are going to use delete. Then what is truncate? Truncate also same. Delete the rows from a table. Then what is the major difference here? So here we can use, okay, here we can use where clause. So what is where clause? You can delete the specific, okay, you can delete the specific rows here. By using delete, you can delete the specific rows, but by using truncate, we can delete all. Delete all. By using delete, you can delete all as well as specific rows. Okay, delete all. So all the features we have by using delete. Then what is drop? See, delete and truncate, it will delete the data. See, delete the rows or delete the data from a table. Delete the rows or data. Very, very important interview question. Okay, next, what is drop? It will delete data as well as table structure. Okay, it will delete the data as well as table structure also. So we'll see the difference between these three now. Select star from employee. So we do have 40 rows. Out of this 40, let's see here, delete from employee. If you run this query, what will happen? It is going to delete all the data from a table. Now, you can use where employee ID equal to 100. So this means what it will do? It will delete only. So that is the reason where class is very, very important. So it's like it is going to filter the data. See, one row it is deleted. Let's try to observe here. Select star from employee. So now we have 39. Now I want to delete 101 also. Yes, you can delete it 101. Now let's see, select star from employee. Now we have only 38. Suppose if I don't use any where class, what will happen? Let's see. Delete from employee. All 38 rows are deleted. So because we are not using the where clause here. Okay, that is the reason. Either you can delete all the rows or specific rows by using delete. Okay, just try to remember. Now again I'll load the data. So it's very easy. Okay, how to load it? Go to employee table, click on this, load data, click on browse. Okay, click on next. Go to view options, headers, skip first line, load the data. Done. Okay, now again let's query. Select star from employee. Yes, we have a 40 rows. Again we have loaded. Now truncate. So by using truncate, we don't have options to delete the specific rows. It will delete entire table data. Okay, truncate table, the table name. That's it. Okay, let me give that where clause. Suppose it will throw an error. Hey, I'm not going to supposed to use where clause. See, syntax error, unexpected where. So this kind of where clause is not going to support in a truncate. So truncate, what it will do? Entire table data, it will delete it. That's it. Okay. Now we will see drop. Okay, drop table name. So before going to perform this action also, I will do load again. Go to table name, load data, browse. See, we are not doing any insert operations. Okay. So by using this, we are doing the bulk load. So all the data I want to just insert here. Yes. Now table data, which it is inserted. Yes, done. Now let's query this. Select star from employee. We have 40 rows. Yes. Now if I perform this drop, what will happen? First it will delete the data and it will delete the table structure also. Now let's see. See, employee successfully dropped. So this means permanently it is removed. Okay, permanently it is removed. Now let's see, select star from. Okay, what we have done? Drop, right? Drop table employee. Okay, see, does not exist or not authorized. Okay, it's already deleted. But why it is showing? What is the issue here? Drop table name, correct. Okay, let's see. See here, we are unable to see this option. Yes, no objects found here. Okay, no objects found. Again, if you want to create, yes, you can create it. Yes, I'll show you here. Just try to see. I have created one table, employee. Okay, table is there. Now I'm going to drop the table. So if you do drop the table structure also, it will delete the data as well as table structure also it will delete. See here, no objects found now. So that is the major difference. Okay, that is the major difference you need to know. Delete, truncate and drop. Delete, truncate and drop. But okay, by unfortunately I have dropped my table. Okay, I want to recover my table back. Okay, you can consider this is your table. So you have loaded 2 rows or 50 rows or whatever it is. Okay, unexpected insert. 1 row it is done, 2 rows. Now let's say select star from employee. In this table, it contains 2 rows. Now let's see, drop table name, drop table name. So table is successfully dropped. Now I want to recover this table. Okay, now I want to get back my table. See, normal databases and all, we need to connect with the DBA team, database administration team. So what they will do, they will take the backup earlier. Okay, so they are going to restore it. But here we do have an option called undrop. See, by yourself, you can undrop the table, undrop table name, drop and undrop. See, undrop, we are going to use it for to recover your table data or table objects. Okay. Now let's see. You can go to select star from employee. You can able to see this 2 rows. Again, I'll do drop, perform these queries and see any data is there, no data. Now undrop table name, and again you can verify this. So these kind of features, see, compared to normal databases and Snowflake, so we do have bulk upload. Okay, instead of writing, okay, we can load the data by using Excel, and we do have a lot of options. But so these are the 2 options which we have learned today, etc. Normally we do have drop and undrop too. So these are the extra things. So compared to normal databases. So that is the beauty of Snowflake here. Okay, now I'll give you this entire classroom notes. Okay, you can go to video and video description. I'll copy paste this. Okay, just what you need to do is, so you no need to write anything. Okay, don't write manually. Just you can copy paste this into your worksheet. Just try to execute one by one. Just try to execute one by one. From video description you can take this. Okay, that is one thing. And so what is the task for you guys? Okay, first to practice this. So whatever we have discussed, okay, just create one database schemas, create one table and insert few values and perform delete, truncate and drop and undrop and select. Okay, so apart from this, okay, I'll show you one thing here. Just to go to Google and type github.com/vi tech talks. I'll give you this link. Here we can see SQL practice. So inside this we have a create table scripts. Okay, see I have given a create table. So this is the HR database diagram. Okay, this is the HR database diagram. One table I'll tell you. So rest you need to practice. Okay, see there are 7 tables. There are 7 tables. Now you guys can tell me I want to create my database as HR. So what I need to do? Tell me. What is the syntax? I want to create a database name as HR. Anyone?
Create database HR.
Yes, correct. See, it should be interactive sessions, guys. Okay, you can talk in your regional language also. If you are not able to understand, that is fine. Create database. If you have any questions, you can ask me. Create database. Okay, HR, correct. See here, HR is created. So that is the ask which I ask. Okay, HR database here diagram. Now I want to create employees table. Create database HR is fine. So inside this, I want to create a schema. Create schema VI tech. So VI tech is my schema. Okay, you can create it. Just do refresh and verify here. Okay, see VI tech. So now we are into HR.VI tech schema. Okay, HR.VI tech schema. Okay, cool. Now I want to create a table. So you no need to write any scripts here. Okay, just go to create table script. So one by one you can create it. Just copy this. Okay, ignore what is primary and foreign keys. Okay, we'll talk about later. Okay, wherever it is there, then you can just remove this. Rest of the things you can just copy and go to your editor. See, create table name. Just try to understand. Okay, what I have written. Okay, this is for testing purpose. Okay, or task or assignment purpose, which I have created already. All the scripts here. Okay, all the scripts. Just you need to try to understand before going to execute. Either you can use. Okay, even you can remove this also. Integer. Yeah, varchar. Okay, we have talked about, right? Even you can use varchar or string. It is going to specify like, okay, 20 bytes. Okay, this is the length. Suppose if you give 2 bytes and if you are going to store as the one, it is not going to accept, because so that is the reason the length is mandatory. Even if you give string, that is also fine. Just don't change anything. Just copy these lines, remove this primary or foreign keys wherever it is. Just try to execute. Okay, this is one table. See, there is one error, unexpected. Just try to see, is there any comma mistakes or full stops? Okay, so the syntax is mandatory. Now table is created. That's fine. See, VI tech, one table is created. Okay, now what you need to do, like this, create all 7 tables. Okay, all 7 tables. Then load script is there, load data scripts. So wherever it is employees, yeah, take this, just copy this all for related to the corresponding tables. Just try to select, all the insert scripts. Just try to run. See, Out of 40 scripts, so it is executing one by one, 8, 9, 10. Okay, let's get complete. Okay. Now, if you see, select star from employees, you can able to see the count. So how many rows are there? There are 40, correct? There are 40. So here there is an option called download. See here, download as the results. Even if you want to store it, right? Yes, you can store it and you can use it for your testing purpose. This also. Okay, there is a download results. So this is our CSV file. Now, what is your task for today? Task is like create all 7 tables. First one, create. Why it is caps? Create database name as HR. Inside that schema, I can create it. Okay, whatever you want. Then next step is, okay, I'll write that also. Create schema. Schema name can be VITech, you can give. Next, create all 7 tables. Then fourth step is load the data. Load the data means, okay, you need to insert the data. Load the data into all tables, all 7 tables. Now I want is, okay, the count of all 7 tables. Just post it in a group. It's like if it is employee 40, then regions table is there, dependents is there, something like this, right? Dependents. Okay, so I need all the count, just count, that's it. Okay, so how many rows you have inserted, that count I need, that's it. See, if you do select star from employees, if you do select star from employees, you will get the count. Yeah, I'll give you this link also in the video description in the classroom notes. Just try to practice. So any questions here so far? Try to practice it and do let me know if you are facing any difficulties, so that I'll happy to assist you in the group. So GitHub
Okay.
URL. So this is the GitHub URL. You can use it. So even in the classroom, right? Okay, see, you no need to type manually, just copy paste all these things and try to execute it. Okay, so how to execute, you know already. Just you need to select this. If you want to execute any SQL, just select this and click on run button or control and enter. Even if you press control enter, it is going to execute. Okay, this is how it is going to work. The task is you need to create all the 7 tables and you need to insert the data, and I need a count of all these table records because it's very important for going forward sessions, which we are going to extract the data from 2 tables or 3 tables. We are going to perform some operations, string operations, numeric operations, and those kind of things we are going to perform. Yeah, that's it for today. We'll see you in a tomorrow session. Thank you. If you have any questions, you can ask me now.